All right, so today we're going to look at graphing sine and cosines again, but this time we're going to focus on negatives, even and odds, and then writing equations given a graph. So starting with negatives, dealing with a negative a value is just like what we do for every other function. Okay, so we reflect it over the x-axis. So here are examples of just the parent functions with a -1 a value. Okay, so it just flips it over the x-axis. So we're used to seeing it like this, right? So we just flip that thing over the x-axis, and instead of going up from 0, 0, we go down, and then I just complete my pattern in that direction. Same thing with negative cosine. We usually start at the top and then do my pattern, right? But flipping it over the x-axis, I start at the bottom and then do my pattern based on my interval. Okay, so let's look at an example dealing with a little bit of everything, including a negative a value. So setting up my acronym here, M-A-P-P-I. A is -3, B is 2, C is the opposite, so pi, and then D is +2. So my midline, +2 means I'm going up. Amplitude, remember, is the absolute value of A, so my amplitude is 3. Phase shift, we have +pi, so that means we're going to the right. Period, 2 pi over B, so 2 pi over 2, which would leave me with pi, and then my interval, divide the period by 4. So thinking about my setup, I need to go up 2, and then I have an amplitude of 3, so I need more positives on the y. So I'm going to set up my axis like that. 1, 2. That'll be where my midline is. So we'll go ahead and draw that in. Then my amplitude is 3, so I need to go up 3 from the midline and down 3 from the midline. So 1, 2, 3 would put me at 5. Down 1, 2, 3 puts me at -1. Okay, whoop. So there's my amplitude from the midline. Now, to figure out my starting point, I need to look at what trig function I'm dealing with. So I'm dealing with sine and my phase shift. So we're starting right pi. So here's where pi would be. And then sine starts on the midline. So my midline's at 2, and I'm starting at pi. So there's going to be my starting point. Now we have to set up our interval. And I'm going by pi over 4s. So remember, pi is really 4 pi over 4, if we think about it in terms of fourths. So I'm just going to add pi over 4s to get one full period. So 4 pi over 4 plus pi over 4 would be 5 pi over 4. 6 pi over 4 would be 3 pi over 2. 7 pi over 4. And then 8 pi over 4 would be 2 pi. Now we take into account my negative. Okay, so that negative a value is going to flip, and I'm going to start by going down. So negative a. So instead of going up from the midline with sine, right? We go down. Following the same pattern, right? So instead of going up to my max, I'm going to go down to my min as my next point. So here. Then back to the midline, up to my max, back down to the midline. And then draw my graph. And there we go. Now remember, this thing can continue, so we just want to put little arrows to represent that, okay? All right, so that's dealing with a negative a value. Now let's look at dealing with negative b values. So if you remember from our functions unit a long time ago, when we had that negative b value, we reflected across the y-axis, okay? But because these graphs, my sine and my cosine functions, are periodic, some weird things happen when I rotate around the y-axis, and that's because these things are either even or odd. So recapping even and odd functions, remember even functions are symmetric about the y-axis. So when I look at this graph here, if I flip it around the y-axis, I get the same thing, right? So xy is the same as negative xy, meaning here's negative x, here's positive x. Those give me that same y value. Because that is the case, right, and it reflects, or it's symmetrical about the y-axis, when I have a negative b value, I can take that thing, whoops, nope, sorry. I can get rid of that, and it's just my normal function, right? Since it doesn't change, I don't need to worry about that negative b value. So when I have an even function, we can drop the negative in front of the b value. So when we have cosine, we have an even function. So if I have a negative b value, we can just drop it, because once I reflect it over the y-axis, it's the same thing. Now, for odd functions, they're symmetric about the origin. Okay, so if I rotate or reflect across the y-axis, okay, so here would be my negative x, here would be my positive x. When I reflect this thing over the y-axis, that's going to take this guy and move it here. Whoa. And it's going to take this guy and reflect it and move it here. So if you notice, that's the same thing as when I have my negative a value, right? It flips it, but then it makes it look exactly like when I have a negative a value. So because this thing is odd, right, when I reflect it over the y-axis, that's the same thing as taking this negative out to the front and making it negative f of x. Okay, so when I have odd functions, remember I can pull that negative on the b value out to the front, because once if I do that reflection over the y-axis, it's really just flipping it like we do when we have a negative a value. So when I have sine, we can pull that negative inside out to the front. Because remember, when we're dealing with these things, we always want a positive b value. Okay, so if it's cosine, we can just drop it. It's even. If it's sine, we take it out to the front and make a negative because it's an odd function. So let's look at an example here. So this kind of incorporates a little bit of everything that we've talked about so far. First things first, I notice it's out of order, so just to make things look the way we're used to seeing, I'm going to rewrite this thing. So we would have y equals 2 cosine negative pi x plus 1/2, and then the positive 1. So first things first, we need to decide if this is even, odd, or neither. So we look at my function. I see that I have cosine. So this thing is even. And remember, even means I can drop that negative. So when I look at my equation here, I can get rid of that guy. So let's go ahead and do my, get all my information. So let's look at MAPI. So my midline is my D value, right? Why do I keep doing that? So there's D, midline is 1. So we're going up. Amplitude, positive 2. C is going to be negative 1/2. So that's my phase shift, which means we're moving left. B value is pi, right? Positive pi. So 2 pi over B. Pi's cancel and I get 2. Interval is period divided by 4, so we're moving by 1/2. So thinking about setting up my axes here, I do have to shift left, so I'm going to want a little bit of the negative x side, and we're going up and an amplitude of 2. So I'm going to set things up like that. Midline first. So here's 1. There's my midline. Now let's go up 2 and down 2 from that midline, right? Because my amplitude's 2. So there would be 3. Down 2, 1, 2, puts me at negative 1. Now let's get our first point. So we have cosine, so we start at the max, positive a, so it's still going to be at the max, right? It's not going to flip down to the minimum. And we're over to the left 1/2. So here's negative 1/2. There's my midline, and we're starting at the max because it's cosine. So there's my starting point. Now we just need to build my x-axis. Based on my interval, we're moving by half. So 0, 1/2, 2 halves, which is 1, and then 3 halves. Now I just follow my pattern. Midline, minimum, midline, maximum. Put my arrows on it, and we're done. Okay. Now, just to mention, right, if this was sine and I had that negative on my B value, I would take that thing out to the front, and then I would have to deal with the negative A value. So it would flip it across that midline, okay? All right, now let's look at writing equations. So sine and cosine graphs are so similar. They are actually only phase shifts of one another. So if you notice, we're basically looking at 2 of the same graphs, just one shifted one way or the other, okay? So for every graph we're given, you can write either a sine equation or a cosine equation, depending on the phase shifts and the reflections you choose. And the thing that makes this, I guess, most difficult is there are an infinite number of equations that can be created to describe the same graph. Okay, so for writing these equations, there's no one correct answer. It's all about how you see it, the reflections and shifts that you see in your head to describe what's going on, right? And that tends to make things a little bit more challenging because I know a lot of us like that one concrete way, okay? But to show you kind of what I'm talking about here, this purpley blue graph is my cosine, right? Now, if I wanted to write that graph in terms of sine, okay, so sine is the black graph there. One way to do it is to shift my sine graph left pi over 2. Okay, so if I shift my sine graph left pi over 2, that gives me sine. And that's what's written here. Okay. Now, if I wanted to go the other way, if I start it with cosine and I shifted it right pi over 2, that would give me my sine graph. And that's written here. And again, that's not the only way to describe this. Just to show you real quick, I could shift my sine graph right 3 pi over 2, right? If I shift everything over 3 pi over 2, it's going to give me my same graph. Then you can get into negative a values, right? If we flipped sine upside down, that would put me here, and then I could shift it right pi over 2, right? So that would give me this graph if I flip sine, and then I could shift it to the right. So like I said, there's a bunch of different ways. We're going to talk about that as we look at examples. And then as you practice it, it's always a good idea to try and think of more than one way of doing it. That way you can just get more comfortable with it. So let's look at an example here. So for these problems, we're always going to write two equations, one cosine and one sine, just so we can practice looking at things a little differently. Now, some things that'll help you out. To find the midline, if we do the max plus the min and then divide it by 2, that's going to give me that middle line, right? That's going to give me the thing that splits that graph in half. To find the amplitude, if I do max minus my min and divide it by 2, that'll give me the height from my midline to the maximum or the minimum. One other thing, when I'm trying to identify the period, we're going to make use of the period of my graph, and I'm going to set it equal to 2 pi over b, because that's what we're using to find my period, and then I'll solve for b in order to get that part of my equation. So let's look at this. First, let's find the midline. So my max is at 6, my min is at 0. So to find the midline, 6 plus 0 over 2, which gives me 3. Okay, and I should have done this earlier, but let's set up our equation, and then as I find things, we'll plug those into where they go. So for sine, or cosine, we would have blank a, we don't know what a is yet, cosine, leave a space for b, x, leave a space for c, and then if we have a d value, it would be at the end. So we just found our d value, right? My midline is my d value. So I know there's a plus 3. Setting up sine so I can plug things in as I go as well. Blank for the b, blank for the c. And the d value is always going to stay the same. So I can go ahead and put that in my equation as well for sine, okay? Now, let's find my amplitude. Max minus min, 6 minus 0 over 2, and I get 3 again. So there's my a. Now, we don't know if a is positive or negative yet. We can play around with that eventually, right? But I know that it's a 3. So I can throw that into my equations. Now let's figure out my b value by determining my period. So remember, your period is when you start repeating. So if I look at my graph, start here, and I finish one cycle here. So this is the length of my period, and that is represented by 2 pi. So the period of my graph is 2 pi, and I'm going to set it equal to 2 pi over b. I know that you guys can probably see what b equals, but to show you kind of the format you're going to use for other problems as well, that's going to be over 1, right? Any number has 1 as a denominator. We would cross multiply and divide, which would give me b equaling 2 pi over 2 pi. So b would equal 1. So we can put that in here. We're going to simplify these equations too once I figure out what's there and what's not. Now we need to identify my phase shifts. So here's my midline. Now thinking about cosine. Cosine starts at the max generally, and then we go through our points. If I look, I'm at my max, and then I go through my key points. So cosine's not shifted. So cosine's not going to have a c value here. So now I have all of my pieces for cosine. 3 cosine. 1 times x is just x, and then plus 3. Okay, so that one's done. Now let's identify any phase shifts for sine. Sine starts at the midline and then goes up to the max generally, right? So in order to get my graph of sine to match the red graph, I would have to shift everything left pi over 2. Okay, so we're going negative pi over 2. So c equaling negative pi over 2. Remember, c is always the opposite. So that means that it would be positive pi over 2. Simplifying things if I can. 3 sine. B is 1, so I don't need to include that. X plus pi over 2, and then plus 3. Now, just to give you another example here, let's say we wanted to look at sine again, but I wanted to incorporate a negative a value. Okay, so we want negative 3. I know it's still sine. B value stays the same. Now I just need to adjust my phase shift, and then plus 3. Okay. So let's think about a negative sine graph before I reflect it over the midline. So that would be here, and then instead of going up, I would go down to the minimum, and then up to the midline. So I would have this shape, right? So to get the green to match the red graph that I need, this time, because I reflected it over the midline because of the negative a, I would have to move everything right pi over 2. So we would have negative pi over 2 here. And again, that's not the only phase shift you could do. If you thought, oh, I can shift this right pi over 3, or 3 pi over 2, then you could have minus 3 pi over 2 there as well, okay? Whew. All right, let's look at one more example of all of this, okay? Again, this is not something that you're gonna master by doing one problem. Okay, you're gonna have to practice this stuff because it's a lot of information going on all at once. So, first things first, I rewrote the x coordinates there, the x values, my interval, just because they didn't show up very well. So we're moving by pi. And first, let's find my midline. Okay, so midline is max minus min, or max plus min. So we would have 1 plus -1 all over 2, which would give me 0. And that's my d value. So setting up my generic formula here, leave a blank for the a blank for the b, a blank for the c, and then d at the end. Okay, so I found out that d is 0. So that's nice, right? That means my midline is on the x-axis, and I'm not going to have anything on the end here of my equations. Now let's find the amplitude. So 1 minus -1 over 2, that becomes plus. So I get 2 over 2, which is 1. That's my a value. All right. Now, let's look at any phase shifts I might have, starting with cosine. So for cosine, we generally start at the max and then go down. So I would have this shape generally, right? So we can shift left pi if we want, or if you wanted to shift right, you could shift right 3 pi. Okay, it's just depending on how you look at it, right? I'm gonna do the shifting left just because. So that means my c value is -pi. So the opposite, I would have plus pi in here. Now we need to find the period. I forgot to do that, sorry. So it starts repeating here. So my period of this graph is 4 pi. So 4 pi equals 2 pi over b. That's over 1. Cross multiply and divide. We get b equaling 2 pi over 4 pi, which gives me 1/2. So that's my b value for both, okay? So cosine's done. Y equals cosine 1/2 x plus pi. Now let's finish up sine. So sine usually starts at the midline, and then we go up to the max. So I usually have this shape. So if I look at what I have on my green, right, my green graph that I need it to be, if you notice, that's just a reflection over my midline, right? So in order to shift that down to here, I could just make a negative and not have a phase shift, because that would give me this now. So that would give me negative sine 1/2 x. So those are one possibility, right? Now, let's look at doing it one more time, okay? So something different. Let's start with cosine. And let's just say I want to make it negative, just because. So we'll make it -1 cosine. I know that my b value stays as 1/2. Now I just need to figure out my phase shift. D is still 0. I just need to figure out the phase shift when I make cosine negative. So if I flip and look at it before my phase shift, negative cosine would put me at my minimum. And then I would go up So I would have this shape, right? In order to get it to match my green graph, I would shift everything right by pi. So if I had a negative cosine here, my c value is positive pi, so the opposite, I would subtract the pi on my equation. One more real quick. So let's make sine positive this time. So we would have positive sine. I still have the 1/2 b value. I don't know my phase shift, and d is still 0. So negative or positive sine would put me here. So to get my graph to match, I would have to shift right by 2 pi. Or you could shift left 2 pi, right? Again, it's just depending on how you see it and what you see first. So if I did 2 pi to the right, that means I would be subtracting 2 pi.